Our last section of notes in this section is on function form. Function form is sort of like in the last section where we were solving formulas for one of the variables. We're just going to be taking an equation that looks like this one, for example, y equals 3x plus 2, and solving it for y if the y was not already by itself. So we're trying to rearrange an equation. So we're going to do two examples here. We'll start with 3x plus y equals 4. When you're asked to rewrite it in function form, that means to solve it so that the y is by itself. So at this point, the y is not by itself because it's being added with the 3x. And the inverse of adding 3x is subtracting 3x. So we're going to subtract 3x from both sides of the equation. On the left, 3x minus 3x is 0, and 0 plus y is y. It's sort of like those 3x's are canceling out. On the other side, I have 4 minus 3x. Those are not like terms, so I cannot put them together. To make this really function form, I do have to have the x part first, though. So you can think of 4 minus 3x as 4 plus negative 3x, and then you can use the commutative property of addition and put the negative 3x first and then the 4 second. So y equals negative 3x plus 4. Just kind of a side note, occasionally you might see one extra step where they take the y equals and they change it to f of x equals. It's the same thing, it's just a different form called function notation. For our next example, negative x equals negative 2y plus 8. Rewrite it in function form. Again, that means that we want to get the y by itself. This y is not by itself because it's being multiplied by negative 2, and then you're adding an 8. Remember, you're going to use order of operations in reverse, and you're going to be using inverse operations. So the inverse of adding 8 is subtracting 8. So we'll subtract 8 from both sides. 8 minus 8 is 0, and negative 2y plus 0 is negative 2y. So it's sort of like those 8's have canceled out. And negative x minus 8, those are not like terms, so I can't put them together. It's just going to be negative x minus 8. And I'm a little closer to what I wanted, but I still don't quite have the y by itself yet. So I'm going to need to take another step. The inverse of multiplying by negative 2 would be dividing by negative 2. So I'm going to divide both sides by negative 2. On the right-hand side, when I do negative 2 divided by negative 2, I get 1, and 1 times y is y, so it's sort of as if those negative 2's are canceling out. On the left-hand side, you can think of this as negative x divided by negative 2 minus 8 divided by negative 2. It's kind of like you're splitting this up into two different problems divided by negative 2. And then we can simplify those. Negative x, remember if there's no coefficient, it's a 1, so that's really like a negative 1x. Negative 1 over negative 2 reduces to positive 1 over 2, or 1/2. And negative 8 divided by negative 2 is positive 4. So now I have 1/2 x plus 4 equals y. I can use the symmetric property, and I can rewrite that as y equals 1/2 x plus 4, which would be my final answer.